Okay, we're ready to look at the assignment for Module 5. Okay, it says generate a sample of 750 using the Pacific region. Okay, so let's open the Pacific region, the house listings by region spreadsheet, and we specifically want Pacific. Okay, so you can see these tabs at the bottom have each region. So we're going to click on Pacific, and we want to do the same thing using the random sample that we've done before. And this question is asking specifically to do a test about the cost per square foot. Okay, if you are selling a house, you definitely want to sell it for the most cost per square foot. So we're going to be looking at cost per square foot. That's going to be our only variable needed. So I'm going to highlight one, delete. I'm going to keep deleting these rows. I'm going to delete the titles too, as long as I remember that this column E is cost per square foot. Okay, so delete. I'm going to delete these columns that we don't need. We don't need our states, our counties. We know it's the Pacific region. Those are list prices. This is the cost per square foot. We're going to leave it. We're going to go to column B, and we're going to delete that. That's the square feet. Okay, we want these numbers right here, the cost per square foot. We're going to use our random sample equals RAND. Let me make the screen bigger first. View, zoom, zoom. Let's look at 150. That's better. Okay. I'm going to use equals RAND. I'm going to double click, enter. Okay, go back to B1. You can use your mouse. I like to use the shift and down, hold down, shift down. Okay, sometimes you can use page down, whatever you're more comfortable with. Okay, now I know that this is a lot, so you may want to use your mouse. You can also use the page down button. We want to use our random number. We want it to go all the way down to the very last line. Okay, remember we want this dollars per square feet. Okay, we want a sample of 750. So after we put a random number in beside each one, we're going to use that sort feature again that we've used before, and that makes the numbers random. Okay, you only need this one column. We're doing something very different from what we did before. Okay, we are not looking at the relationship between two variables now like we did before. We are just looking at this one set of numbers. So your spreadsheet should only have one column of numbers, and those numbers are dollars per square foot. Okay, so I need to go back to the home button, and I need to use my fill down. Okay, this is right here. Let me maximize this so we can see fill down. Okay, now I'm going to go back up to this row, and I want to sort those. So sort smallest to largest. Okay, so now I'm going to take the first 75. Okay, so what I'm going to do, or sorry, not 75, 750. So what I'm going to do is I'm just going to come down. Okay, you can use your mouse, you can page down. I need to get down to where I have 750, those rows of 750. Okay, and when we get down to 750, we're going to delete that column of numbers in column B. Okay, that's just a way to sort the numbers so that we have randomized. Okay, that's the only way you can randomize numbers. You use Excel. Okay, so we're almost down here to 750. I am just going to use this one page to do all my work. So now that I'm at 750, what I'm going to do is I'm just going to delete the rows 751 through the end. I think there's about 1,000 numbers in the Pacific region. Okay, so I'm just going to delete those. Okay, I'm going to go back up to my column B and delete that column. Okay, so now I no longer need this column. So let's go back to see the instructions and let's see what we're going to be doing with these numbers. Okay, so we've generated our sample of 750 and let's look at the instructions. Okay, a salesperson says that the average cost per square foot for this person is $280. Okay, there's a new advertisement that the cost per square foot is $280. Okay, but a certain salesperson thinks that the average cost per square foot in the Pacific region is less than $280. Okay, this right here is our claim. The average cost per square foot in the Pacific region is less than $280. So we're going to do a hypothesis test based on this. Okay. Let's go back to Excel. The claim that we want to test needs to be in our HA, which is our alternate hypothesis. The alternate hypothesis always has less, more, or equal, or not equal. The HA always has equals. Okay, so let's look at our instructions. It says define your population parameter. A population parameter means the variable you're studying. Okay, now our Pacific values, we have 1,000 homes. That's not all the homes in the Pacific region. That is a sample. Okay, so what is the population parameter? It is the mean dollars per square feet in the Pacific region. Okay, we don't know what that is. Why don't we know what that is? We only have 1,000 homes in the Pacific region. Write your null and alternate hypothesis. Okay, so HO, the mean equals 280. HO always has equal. HA, let's go back to that sentence that we talked about. The salesperson claims the average cost per square foot in the Pacific region is less than 280. So the mean is less than 280. Okay. Let's go back to the instructions. The hypothesis test, interpret the results using a significance level of alpha equals 0.05. Okay, significance level equals 0.05. That means we're going to allows 5% error. Now let's talk about why there is error. How many houses do we have? We have 750 houses. Is that all the homes in the Pacific region? No. So the average that we're going to find, the mean, is not exact. Okay, we can't know for sure what the average cost per square foot is. We don't have all the data. Okay, so we've got our parameter, null and alternate. Specify the name of the test that we'll use. Okay, we will be using a t-test. Identify whether it's left, right, or two-tailed. Okay, look at the HA. The HA always tells you what type of test. It matches HA. Less than, this is a left-tailed test. Okay, and your significance level we have is our 0.05. Okay, sample summary statistics. We're going to get our descriptive statistics, mean, median, standard deviation. Okay, you can use your analyzed data, but some people have had some difficulty with that. So let's just do this. Mean. I'm going to go to formulas, more, statistical, average. Okay, now that's a lot to scroll through. You can just do A1 colon A750. Okay, hit enter. I'm on my Mac, so I'm going to click done. Okay, what else? Median. So I'm going to type median just so I know which is which. Formulas, more, statistical. Median. Same thing, nobody wants to scroll through all that. A1 colon A750. Standard deviation. Formulas, more, statistical. Okay, now we want the standard deviation sample. This is a sample because this is 750 houses. It's not a population. Population means every house in the Pacific region. So sample, A1 colon A750. You're either going to do enter or done depending on what kind of device you've got. Okay. Now I want these decimals to have a little bit more decimals. So I'm going to use this increase decimal. Okay, same thing here. I want to increase the decimal. Okay, all right. Next, we want to do a histogram. Provide a histogram for your sample. All right. Okay, I'm done with my formulas. Now, what do I need? I need all my data in column A, and I'm going to do a histogram. Okay, please remember you should only have one column of numbers. Okay, so that means we need to go all the way down and highlight all of our numbers. Let's talk about a histogram while we're doing this. A histogram is a bar graph, and it puts the numbers in like groups. Okay, think about if you've ever done a survey and at the end it says, what is your age? And it might say 18 to 25 is one age group. The next age group is 26 to 30. The next age group is 27 to 35. And then that is a histogram would be counting how many people are in each age group. Okay, so we've got all these numbers here, and we're going to let Excel do a histogram for this. So we want to insert recommended charts. Okay, this is a histogram. Okay, it's a bar graph. Okay, and let's see what this looks like. Okay. Now, what does all this mean? Okay, first I'm going to give it a title. Click in the box. This is cost per square feet. Okay. We're going to use this add chart element over here. And we want some titles. Okay, we want our axis titles. Add chart element, horizontal. Okay, so this is cost per square feet. Okay, let's look at this first set. Okay, let's look at this first set here. This first set says 104 to 168, and it's just barely under 200. Okay, now see how when I hover over it, it says 193? What does that mean? That means 193 houses have a cost per square foot in this range. Okay, let's look at one more. This one says 168 to 232. Let me come up here, and when I hover over it, it says 282. 282 houses have a cost per square foot between 168 and 232. Okay, let me double click back in my graph. So these numbers are here are there are frequencies. Okay, let's look back. Oh, let's go ahead and make another title. Okay, so double click in there, add chart element. Let's do a title for here. Okay, double click in there. And let's call these frequency. Okay, so that's frequency. Okay, you're going to want to take a screenshot of that and you will insert it into your template. Okay, provide a histogram, we did that. Write a sentence describing the shape, center, and spread. Okay, see how most of the houses are over here in the lower values? Okay, that's called right skewed. And we can say most houses have a cost per square foot between, the lowest one is 104. Okay, I'm going to say most of them are in these first two categories. Okay, between 104 and then 232, the largest there. Okay. All right, the conditions to perform our test, let's see if they've been met. Okay, what does that mean? The conditions, we have a random sample and it's more than 30 values. Okay, so that's our conditions for our t-test. All right, so now we're ready to do our calculations. We're in the calculations section. Calculate the p-value, test statistic in regard to the normal graph, and how the p-value relates to the significance value. Okay, so it gives us our formula, the mean minus the target divided by the standard error. So that means we're going to have to go back and look at our mean and our standard deviation. Okay, the mean is your regional mean and the target is 280. That's because our hypothesis test says 280. Okay, so we need to find the test statistic first. And we're going to use our Excel to do our calculation. Okay, this is going to be called the test statistic. And we need to do our formula. Okay, so our formula, we're going to do the mean, the sample mean. Okay, here's our sample mean. The target is 280. Okay, the target is 280 because it is the hypothesis test. Okay, we divide by the standard error, so let's calculate the standard error. Okay, what is the standard error? The standard error, I'm just going to write what it is. It's the standard deviation divided by the square root of n. Okay, n is the number in the sample, which is 750. Okay, we got to divide by the square root of n. So let's say we're the square root of n. Okay, how can we take the square root of n? Equals formulas, math, SQRT. What are we taking the square root of? We're taking the square root of, now you can just type 750. Okay, enter or done. Okay, so that's the square root of n. Okay, so what is our standard error now? Standard error, what do we say our standard error is? Standard deviation divided by the square root of n. So I can just do a little calculation right here. Equals, it's the standard deviation divided by the square root of n. Here's my standard deviation. divide. Here's my square root of n. Enter. Okay, so there's my standard error. Okay, so what's my test statistic? Okay, let's write that as a formula. Okay, you take your sample mean, you minus the target, you divide by the standard error. Okay, so let's calculate it. Now, why is the parentheses important? Because you need to subtract and then divide. So I'm going to type equals, parentheses, where's my sample mean? Here. Subtract. The target is from the hypothesis. We're saying how far is 268 from 280? So minus 280, close parentheses because I need to do that first. Divide. Okay, where's my standard error? All right, it's over here. I did the calculation first. The reason I did that standard error calculation is so we didn't make any mistakes in entering things with the order of operations. Okay? Okay, so there it is. That's our test statistic. Okay, where are we? All right, we did our calculation. Calculate the p-value. Okay, let's go back. What did we say it is? We said it's a left-tailed test. Okay, it's left-tailed. In your instructions, it tells you which one to do. Okay, so we want the left-tailed test. So this is our p-value. We'll talk about what this means in a minute. Okay, in your instructions, it gives your 3 different options. Okay, left-tailed, we just use t.dist. More, statistical, t-distribution. Okay, so here we're going to put our test statistic. Here we're going to put degrees of freedom. Okay, now we haven't talked about that. Degrees of freedom is n minus 1, meaning the number in the sample minus 1. 751 minus 1 is 749. Okay, cumulative, you put a 1 to mean yes. Okay, so there's our p-value. What does that mean? Essentially, it means the probability that HO is true. Okay, so I'm going to write a rule here. If the p-value is less than significance, reject HO. That means if you reject HO, you believe HA. There is enough evidence to support the claim that the mean cost per square foot in the Pacific region is less than 280. If the p-value is more than the significance, fail to reject HO. There is not enough evidence to support the claim that the mean cost per square foot in the Pacific region is less than 280. Okay, so let's talk about what each of those means. Okay, so what does this one mean? Okay, if you reject HO and believe HA, that means you believe the mean cost per square foot in the Pacific region is less than 280. Let's talk about what this means. If you fail to reject HO, means you don't reject HO, you keep believing HO. Okay, so what does this mean? Believe the mean cost per square foot in the Pacific region is 280. Okay, so that's our test decision. Our test decision is one of these. Okay. One of these two things. Okay. Remember, our significance is 0.05. Okay, so let's look at my sample. Okay, when you compare decimals, you have to line up the values. Okay, so we're going to be comparing 0.029, our p-value, to 0.05, our significance. Okay, so we're lining up our zeros. Let's look at these two things. Okay, look at the decimal. They both have a 0. Okay, so look at the next number. Look at the second digit. This digit is a 0.02. This is 0.05. Okay, so they both have zeros for the first digit. 2 is less than 5. So what does that mean for my sample? The p-value is less than the significance. Reject HO. There is enough evidence to support the claim that the mean is what? Let's be specific. Cost per square foot in the Pacific region is less than 280. Okay, so that's our test decision and our conclusion. And how does your test decision relates to your hypothesis? Okay, so this is what our test decision is. Okay, so let's talk about what this means for the and. Okay, the salesperson has a mean cost per square foot of 280. But the Pacific region, we found to have a cost per square foot less than 280. Okay, what's this mean for all this? Salesperson sells homes with higher dollars per square foot. Okay, so our salesperson is getting more money per square foot for his or her clients. Okay, when you're selling a house, you want to get it for the most dollars per square foot. Okay, so that means the salesperson is doing better. He's getting more money per square foot for his clients than the rest of the Pacific region. Okay, we're saying the Pacific region is, the average is less than 280, but the salesperson's is 280. Okay, remember, let's go back to what our parameter is. Our parameter is not this specific person. The salesperson has a record of all his sales, his or her sales. Okay, what is it that we don't know? We don't know all of Pacific region. That's what we're testing. Okay, we know what the salesperson has, 280. What don't we know? The Pacific region. Okay, so that's how you'll write up your assignment, and be sure to screenshot your histogram and insert it there in the template. That's the end of our lesson.